Okay, well, thank you for inviting me, and I appreciate being here today. We had a few bugs, and interesting. The inspiration for today's talk was first I was invited by Sarah um, and other folks, Lindsay, but this fall I hosted a climate change and human response lecture series at the University of Tennessee, and I had 32 talks by 29 different speakers working all over the world, including several of the folks here today. So their talks all went without a hitch, although I didn't have to give one myself. So that's probably why there were bugs in the system. But these are the topics that we discussed: archaeological and architectural resources that are threatened by climate change, human cultures and language, health, disaster management issues. Meg gave a great talk on that, information management, curation, forensic studies for disaster victim identification, and combating climate denialism. Now, all of these talks were recorded and are available, and my email was on the first slide. I'm going to be giving a lot of information today, so if I go a little fast and you don't have time to read every word, realize that you'll have the talk posted later and you can go back through and look at the slides. I'll also be happy to send you slides as well. Just email me and I'll send you the slides and also the links to any of these talks. Well, today we're going to look at two big questions. How does climate change threaten cultural heritage, and how do we respond? We all know there's a tremendous amount of interest in climate change in recent years for obvious reasons. One of the things I did was look at the Society for American Archaeology papers. I looked at every program for the last 30 years and looked for the occurrence of words like climate change, climatic change, and then Anthropocene. And you can see from here that basically in the 90s, there was some interest, some papers, but it's really the last 10 years that the subject has taken off. And it's only been since 2012 that the first paper used the term Anthropocene, at least in the title. So I'm going to talk a little bit about climate change, and good sources of information are freely available online and can be easily downloaded. And if you want more than you ever wanted to know, but they're fun reads, just do a search on IPCC or the National Climate Assessment. Those are two of many. There are many other programs, but you can get these reports. These are just examples of the report. You can download the reports. They have remarkable images, many of which I've used here. And these are two recent reports that came out just in the last year. The United States government has been doing national climate assessments as well. And that's another source of good information on both climate change information and also the impacts of that. Now, a wonderful paper that's appeared recently by Tim Kohler and Marcy Rockman is the IPCC, a primer for archaeologists. And basically, I urge everyone to read that if you're interested in seeing what the IPCC is, but then how archaeologists can contribute, how we can make what we have to offer more available both to the IPCC and to the world at large. And in the upper right, you see the Keeling hockey stick curve. That's basically surface temperature and carbon dioxide, showing that the two are related. And the hockey stick, the end of the stick where you hit the puck, is because both temperature and CO2 have been going up pretty markedly in recent years. So basically, we know from ice core records that CO2 and temperature have been in lockstep, in tandem, almost exactly in tandem for the 800,000 years now. These are records from Antarctica. And when you superimpose these cores, there's no doubt. So if anyone says greenhouse gases and CO2 don't relate to temperature, particularly global temperature, we have information that's unassailable, as you can see here. Now, atmospheric CO2 is increasing. We know this. It will continue to do so for some time to come. Basically, right now, as of a month ago, the latest data, we're at 412 parts per million CO2 in the atmosphere. The long-term average from what I just showed you is between 200 and 300 parts per million. That's glacial and interglacial times. We're way beyond that now, which is one reason why temperatures are rising. Now, just some brief terminology. Um, there are emission scenarios that are variously described. The representative concentration pathways is one way this is done. Basically, they're low emissions to high emissions. You'll see these in some future slides and discussions. So I thought it important to provide you with where you could get this information. Now, I'm not expecting you to read all of this time. There obviously won't be time for that, but you can see that an RCP of 2.6 is green. That's assuming emissions peak about now and rapidly decline. We're probably not going to see that. And they get progressively higher emissions. And then RCP 8.5 is assuming there's no effort curb emissions, minimal effort. That's bad. That's what we don't want to see. And you can see atmospheric CO2 could rise to 940 parts per million by 2100. Now, these pathways have implications for global temperature. And this looks like a complex slide, but it's just a whole host of different pathways, different scenarios. But on the right, you can see that with an RCP of 8.5, average global temperature will go up 3.2 to 5.4 degrees centigrade. That will cause a lot of effects. Even where we are right now with emissions peaking and declining, we're still going to see an increase of about 0.9 to 2.3 degrees centigrade. So we're kind of in a historical trajectory moving forward. Now, another terminology or way that emissions are accounted for is in terms of petagrams of carbon. And that's in the atmosphere, in the ocean, whatever. But a petagram of carbon is 1 billion metric tons of CO2. And you will see emission scenarios where they talk about the numbers of petagrams in the atmosphere, 1,200 and so on. And basically, the annual emissions are controlled by such things as fires, air-sea gas exchange, and other things that are listed in this chart. And again, this is just something to be aware of because, again, we don't always use the RCP terminology. Now, there's a fairly new terminology, at least in the last few years, that talks about SSPs, which are societal strategies in climate change. And these are basically the nature of the way societies structure their emissions. Depending on their climate policies, emissions will be either low or high. So it's another scenario that by which climate information is looked at. Now, today I'm going to be talking about slow onset and climate change and how that relates to cultural heritage, looking at things like sea level rise, permafrost melting, changes in precipitation and temperature, changes in biota, ocean acidification, changes in health and mortality. Those are affected by these climate change effects, and then migration. And then those are slow onset effects, but then sudden changes in these variables, the first 5, lead to what are known as extreme weather events. So basically, looking at sea level rise, there are a number of scenarios for sea level rise. Again, those from low to extreme relate to the RCPs, the emission scenarios we've talked about. There are a number of possible scenarios. We don't know what sea level rise is going to be. It depends on what we do now and moving forward. We just know it's going to happen. One of the things that my colleagues and I have done is look at the effect of varying rates or varying levels of sea level rise, 1 meter, 2 meters, 3 meters, and so on, to show that there are thousands of archaeological sites at risk here in the southeastern United States alone. We're continuing to grow this database. Someday we hope to get Mississippi involved. We do have information from a lot of other states and would like to do this similar analyses moving forward. Now, this isn't the only such scenario that's been done. In a number of parts of the world, comparable studies have been conducted. World Heritage sites in the Mediterranean basin, for example, have been looked at, again, in terms of sea level rise. This is what's called a simple bathtub model. Basically, sea level goes up, terrain gets covered, and sites are covered. So there are other parts of the world where these analyses have been conducted. I'm just showing you these here, but there are others. I just reviewed a paper a couple days ago, in fact, for another part of the world that since I reviewed it, I can't really talk about it. Well, it was a wonderful study. So basically looking at World Heritage sites in the Mediterranean basin and which of them are threatened and to what extent. Now, there are other sort of guides or studies of cultural resources that are threatened. And what I find is interesting is the doomsday list, which is threatened lighthouses. And there are 56 on this list. And I looked it over pretty carefully. I've done archaeology, that's work I did at Body Island. I've also worked at Cape Hatteras. Used the lighthouse for a datum because I said, surely that will never be moved. That was done in 1990, and then they moved it 10 years later. Body Island's at 10 feet. I'm honestly not sure, but that it won't be threatened by storm surge, things like that as well. So I would expand this list a little bit. The Cape Hatteras light is an epic example of how we deal with climate change. In this case, storm surge, the erosion of the beach. It was moved 3,000 feet inland. 4,800 tons. That's an immense task. I think it wound up costing something like $10 to $20 million, which, considering it was saved, isn't really that much in the great scheme of things. If you're wondering, a Saturn V rocket weighed about 3,100 tons. So we're used to moving large vertical objects. The Saturn V being, you can think of it as the Cape Hatteras. What's also important, though, is the Kennedy Space Center is at about 10 feet, 3 meters. There's already barriers being put in place immediately around the margin on the sea level side. This is another area where small rises in sea level coupled with storm surge will cause problems moving forward. Now, it isn't just dramatic sites like Jamestown or the Kennedy Space Center. Anybody living near the coast is likely to be affected. The Union of Concerned Scientists has looked at residential and commercial properties, and there are 2.4 million residential properties at risk and over 100,000 commercial properties. And that's just projected sea level rise this century. So over $1 trillion by their estimates. So many of these sites many of these residences and buildings are unquestionably historic. Now, that's just the coming century. There are much greater impacts from sea level rise after 2100, extending far into the future. One way you can think about this is, once you melt ice, it doesn't immediately reconstitute. Think about the ice caps over Antarctica or Greenland. They took thousands, tens of thousands of years to accumulate. If they melt in a few centuries, it's going to take tens of thousands of years of snowfall to build them back up. So there are studies of projected sea level rise based on emission scenarios. And in the upper right, you can see those PCG, the 1280. That's one scenario. Just different sea level rise scenarios and how they play out. Now, archaeology, of course, provides a deep time depth perspective, both in the past and moving forward. We're aware that during extreme glacials, global carbon is low, temperatures are low. The mid-Holocene was about the warmest period of the current interglacial up to the present. You can see these comparative charts showing that we're literally off the charts into uncharted territory. We're about at the maximum that during the Eemian interglacial about 110,000 years ago. The temperatures were close to what they are now and a little higher, but we're really getting into the projections are literally things we haven't experienced, at least in the last 800,000 years. We're also looking, we meaning the scientists involved in this, the references you'll be able to look at later, projected sea level effects going forward 12,000 years. The things we're starting now are going to continue to have impacts thousands of years into the future. So it would be nice if we stopped emitting carbon right now to say, yes, there'll be no changes. There is still going to be sea level rise occurring, not as dramatic, of course, if we don't control the emissions. But moving forward, these are things we're going to have to consider. Regarding the melting of the permafrost, we're all aware that the Arctic ice cap is retreating. And indeed, with various scenarios, we may or may not even have an Arctic ice cap by the end of the century. And there are a number of emission scenarios. You can see that if we do nothing to curb emissions, we will lose the Arctic ice cap by the end of the century. This has feedback effects because light reflects light. That's the albedo effect, and that will cause increased warming as well. So how this relates to the permafrost is that no colder climates in northern latitudes, the permafrost melts. We're seeing this happen now. These slides are just to show you the extent of permafrost. There are close to 23 million square kilometers of permafrost. About 24% of the exposed land surface of the Northern Hemisphere is in permafrost. We're talking about a huge area that is being affected by climate change. And basically, here in the United States and in Canada, there's somewhere between 6.8 and 8.4 million square kilometers of permafrost alone. The rest of it is in the old world, Asia, and so on. So huge areas to be affected. This relates to archaeological survey and so on, because we know that as the permafrost melts, we're seeing news items almost literally on a daily basis, at least weekly, about things that are being found as they're unfrozen, as permafrost is melting, as they're being exposed. Everything from a very early dog, an extinct woolly rhinoceros. You're all aware of kurgans from tombs with remarkable preservations. The bottom slide shows a kurgan filled with ice, but as it thaws out, again, remarkable preservation. The issue with this is it's remarkable preservation for a short time, and then the items deteriorate very quickly, especially if there aren't archaeologists who are recovering, stabilizing, conserving them. So the permafrost offers a vast challenge comparable to sea level rise in terms of cultural resource management, a remarkable preservation, but also extensive efforts to survey, find, recover, conserve, and maintain. Looking at another area, we know that there are going to be changes in precipitation and temperature with pretty dramatic changes expected this century. This is just groundwater. It was once said that perhaps conflict in the 21st century will be more over water resources than things like oil. Hopefully not, but we'll see. There are very detailed studies of given differing emission scenarios, how precipitation changes will play out in different parts of the world. Again, the low emission scenario on the left, the high emission scenario on the right, more dramatic changes. These are changes in biota, and there are going to be changes in the ranges and distribution and incidence of plants, species across the world, just as there will also be changes in marine resources as well. But this is vegetation mapping, just showing changes and where communities are located. As an example of this, the tree line in the mid-Holocene, which is basically the taiga steppe boundary where the trees, the forests give way to steppes or taiga. Basically, it was 500 kilometers north in the mid-Holocene. We're going to see comparable effects only instead of playing out in hundreds or thousands of years, much faster. And whether the plant species respond that quickly or not, we don't know. In many cases, they may just die rather than slowly move north as they did in past times. But we see this examples in the Blue Ridge where we see trees dying from various causes, heat and acidification and so on. So another area of concern is ocean acidification. And I'll come back to how the changes in temperature and biota affect cultural resources. They relate to how people respond primarily by movement and so on. But ocean acidification, basically that chart on the upper left basically shows that as the CO2 in the ocean increases, the more we put into the air, there's an exchange between the ocean and the land. The more CO2 increases in the ocean, the more acidic the ocean becomes. This causes issues for anything that takes up calcium carbonate in its shells, for example. So it affects a lot of organisms in the ocean. And then, of course, ocean acidification, which will be a topic of our lecture here, affects archaeological resources as well. Now, how does this affect people, these changes that we'll see? A remarkable paper that just appeared deals with changes in the ideal human temperature niche, places on the planet that were considered ideal for human occupation in the past, and then projecting where these will be moving forward. And there are going to be dramatic changes just in this century alone. And you've probably seen these maps showing how the ideal niche where people will live, considered suitable areas, although people lived in a lot of other places as well, are going to move appreciably north just this century. Going back, you can see those changes in the ideal niche, and they're going to be more pronounced if we don't curb emissions. This is the most dramatic scenario, but it's still movements of hundreds of kilometers. Indeed, it's been argued that in some parts of the world, the temperature will be such that it will be threatening for human life. People, it will be so hot people can die of heat stroke. And this is a study that appeared in the Lancet that basically looks at the numbers of excess deaths, a term sadly we're familiar with the current pandemic. There are going to be more heat-related excess deaths this century and fewer cold-related excess deaths. And these are just showing the trends in different parts of the world. Closer to the equator, much more greater likelihood of excess deaths from heat related. So those are things that we're looking to see. Those are basically slow effects. They may not seem like it by geologic time, but there are extreme weather events we also need to consider. And basically this is the definition from the IPCC, which is an extreme weather event, is an event that is rare at a particular place in time, but that if what happens goes beyond, say, the 10th or 90% of probability in terms of a function of such observations, then it's considered an extreme event. I'm sure we've all seen this chart showing that the numbers of these events, typically storms, hurricanes, things like that, have been increasing, and they're going to continue to increase. This is just in the last 50 years, 60 years, since 1960. A classic example of this is Hurricane Sandy in 2012, which caused intensive flooding, storm surges with impacts on people, structures, and so on. We're going to be seeing more of these. And combination, slow onset change coupled with increasing extreme weather events will lead to mass movements of people in the years to come. So where are they going to go? Where will be healthier and safer places for people to live? How many people are going to move? And how is this going to impact cultural resources? Basically, there's a concept called managed retreat, which means not just moving away from the seacoast, although that's the way it's sometimes thought, but it's moving to areas that are better for human existence. And the estimates vary, but potentially, this is just a map of the percentage in each country. Australia, for example, 25 to 50% of the people, most of whom live around the coast, are going to be needing to move to some degree, to some extent, inland. So we're looking at potentially, no doubt, hundreds of millions to potentially billions of people having to move in the century or so to come. Unfortunately, while it's nice to consider, protection in place is not really a viable option in most places. We might be able to preserve a few places with seawalls. They are going to have to be pretty high, as these fanciful scenarios, the lower right, show. But there have been studies, the references below have estimated the cost for preserving coastal areas, and the estimates are in the trillions of dollars. And when you think about what you need to use to build the seawalls, earthen berms, for example, you're going to cause incalculable damage to the areas where the fill comes from. So it's not an option, and then this will disproportionately affect some groups of people as opposed to others. We might save perhaps enclaves where there's tremendous historic or unfortunately wealthy people have architecture, but most of us are probably not going to have that option. Now in the Southeast alone, this is from the DINA study, there are roughly 3 million people who are going to have to move this century due to sea level rise. This is showing them by state. The largest number, not surprisingly, is in Florida, but that's just in one part of one country, 8 states in one country. Now, when people relocate, it's going to mean development in the areas where they relocate to, and of course, the loss of cultural resources in the areas they leave. And this is not only historic structures, but it's also their landscapes, sacred areas, archaeological sites, cemeteries, the community, the fabric of life is going to be affected. And many of the talks that we heard in the fall and visiting lecture series were how wide aspects of culture are affected. So how do we address cultural resources moving forward? Well, one thing that we need to do is we need to continually refine our modeling of what is threatened and how it will be affected. A wonderful paper by Reeder, Myers, and McCoy evaluated the effects of rainfall and storm surge with regard to Hurricane Harvey in Texas. They compared the bathtub model, the data that I had done, and showed that far more archaeological and historic sites were threatened when you consider the excess rainfall and the flooding that it caused. So that's just in a matter of a year or two, we're seeing wonderful refinement of our models. We need to involve many more parties and people. All of us are stakeholders. Every one of us is affected by this. And I think just a wonderful example is the Poke Island shell ring that a number of the people here, Karen and Meg and others, are involved in, is a fabulous example of collaborative partnerships between agencies, state and federal, and many volunteers. And it's also an example showing the scale of the challenge, excuse me. Large excavations are resource-intensive efforts. They require a lot of collaboration and careful planning, long-term information management and maintenance, curation, analysis. They take years to conduct, and in real cost, hundreds of thousands to millions of dollars. They're not inexpensive. Now, these impacts, again, aren't exclusively related to coastal areas. This is what excess rainfall and flooding has done along the Tennessee River. You see a historic, where you see a structure here that's literally falling into the river along the Tennessee, undercutting banks. I've had experience in dealing with one site, the Mound A at Shiloh, a national landmark, which was literally being undercut and eroding into the Tennessee River. So this is a picture on the right of the 80-foot bluff face with a 20-foot main mound atop of it. And you see on the lower left, you see an attempt to riprap it was made, and there was still erosion occurring. Now, at Shiloh, over 4 field seasons, we spent close to 4,000 person days conducting excavations. Another large project on the scale of Poke Island. And these are just shots of the field work showing the scale of the effort. These are things that are going to be needed. We had over $1 million in the budget for this, and we had a lot more planned, but the mitigation was never completed. The funds were not, they went away after a couple of years. Basically, the mound is still threatened. I'll come back to that, but it took roughly 10 years to write the report. You can get that report online. You can download the PDF. And just to give you some sense of the curation effort, these are the kinds of digital appendices we have. There's also hundreds, if not thousands of cubic feet of materials that were recovered. You can see the digital, it's something like 15, 16 gigabytes of digital data. These are things that need to be maintained moving forward. Now, there are unanticipated consequences of doing this work. We learn a lot of new things about the human past and present. So while there's a lot we're going to lose, we're going to also learn a lot. One thing that we learned at Shiloh was that the appearance of some of the mounds built by First Peoples was quite different than expected. You see on the left that thin red veneer. We peeled that back. On the right, you can see that it was basically covering one of the stages of the mound. So an unanticipated consequence. Another unanticipated consequence from recent shell ring research that Sanger and colleagues documented at the McQueen shell ring on St. Catherine's Island, they found a piece of copper that had come from the upper Great Lakes. Copper from the Great Lakes had been found in the Mid-South and other places. We know that this late archaic, roughly 4,000-year-old exchange network, trade network, however these pieces were passed, was much larger than we had traditionally thought. So another unanticipated consequence. So major challenges we have is determining what will be lost and deciding what will be saved. We need a collaborative consideration of what should be done to maintain the fabric of our cultures and civilizations. And we need a proactive approach trying to maximize what can be saved, a long-term approach rather than short-term ad hoc responses dealing with one or a few items. So we need diverse and iterative approaches in our response, collaboration and participation by all parties, consideration of a wide array of cultural and research concerns, designing appropriate fieldwork and analysis efforts, making sure what is saved is maintained for the long term, and then making sure that the results at every stage of the process are publicly reported, widely shared, and guide subsequent investigations. Now, there are remarkable documents out there that can provide guides for us. This is a World Heritage Center report that came out in 2007. I'm not going to go over the details of it. They offer strategies for moving forward, and many of the people here are doing them, living them, and these are guides. Another wonderful guide is the climate change strategy published by the National Park Service, led by Marcy Brockman. Again, a series of overarching goals where you basically understand the problem, understand the scope of the response, and you integrate strategies, and then you share the results. And that's a simplification, but a wonderful document. There are other documents just pointing to the scale of the problem by many agencies, not just the National Park Service. Of course, the Department of Defense takes this very seriously because of their infrastructure is vulnerable. The National Park Service, of course, for its own infrastructure, but also for historic resources. And then the Union of Concerned Scientists did a wonderful study of national landmarks at risk. Another wonderful document I found is the Coastal Adaptation Strategies Handbook put out by the National Park Service in 2016. And most recently, we've had documents, an issue of the Proceedings of the National Academy on Archaeology, Climate, Global Change, with some of the people here. I know, Sarah, you're an author of this, one of the authors of one of these papers. There's also Public Archaeology and Climate Change, a recent book that deals with these matters. So we have lots of sources to go to, but we also need to ensure that moving forward, we involve all the impacted parties and that they're involved as full partners. And these are a number of volumes talking about approaches that can be used for collaboration to decolonize our traditional approaches and so on. It means involving all the stakeholders, not just archaeologists, not just resource managers. We need to be talking to people impacted by this. In fact, the planning needs to be broad-based and go beyond traditional approaches. So again, we must decolonize our practice and build our capacity, considering multiple perspectives and voices, not only in the planning, but also moving forward in our reporting. We have to be careful about what we consider significant sites. If we're going to try to rescue what we think is significance, we should be aware of biases. Louis Bork has done a wonderful study, which he basically shows that many World Heritage sites reflect complex societies with hierarchical social political organizations, not more egalitarian forms of organization. Basically, we consider significant those sites which are like our own society, perhaps. So we have to try to overcome those biases. Now, earlier large-scale resource management programs developed large-scale mitigation plans. This is an example from the Russell Reservoir. I'll be touching on it a bit moving forward, because I think these reservoir projects are a great example of how you can consider a wide range of cultural resources. This is the Russell Reservoir. It was built in the late 70s, early 80s on the upper Savannah River, and basically flooded 210 square kilometers. That number will be important. 732 sites were found in survey prior to the flooding, which then guided selection of archaeological sites. That's 1 per 71 acres, by the way, which that number will come back to a bit later. And the cost of this program was about $5 million at that time. Now, it was and pre-contact sites were examined in the mitigation. Earlier work perhaps focused not so much on a wider range of structures and sites. These are just some shots of the large-scale field work that was undertaken. This is at a late archaic site called Sarah's Ridge. It was the first South Carolina Archaeology Day poster in the painting in the lower left. This is another site, a late archaic site that was found beneath a midden, a midden that was about a meter below the surface, with stripping and then excavation taking place. This is the Rutgers Bottom site, which was a largely pre-contact village. These are palisade and ditch features with openings. And you can see faintly in the lower right a line of posts that are on the inside of the ditch. Large area stripping took place. And in the upper left is a painting of the village, a reconstruction of the village, and many of these structures, the central post, the council house, were all tied into features at the site. And here's an example. The upper left shows the field. When it was first surveyed, there were half a dozen artifacts found. A subsequent test pit found hundreds, going back to several meters. So a large mitigation program was undertaken with surface collection, large area stripping, and then it goes from an unfortified to a lightly fortified to a more heavily fortified late contact village. So that's an example of one of the sites. Now, in the reservoir, industrial archaeology also took place at a number of mill sites. oral history of affected populations took place. In particular, the African American culture in the area was examined in detail as part of this project. And again, for 40 years ago, this was unusual. Now, of course, it would be common, but at the time it wasn't. Architectural documentation occurred. This is just giving you a sense of the scale of the challenges we face. Many structures would be lost. And while some were relocated, most were not. So relocation of structures like we saw with Cape Hatteras is something we have to consider moving forward. What do we save? What don't we save? Where do we relocate them? How far do we relocate them? Another unanticipated consequence of this work in the Russell Reservoir was that it became evident that the area was abandoned or depopulated. I don't want to say abandoned because there were still at least some people there. But over time, the lower valley was depopulated. And climate change appears to have played a role. Incidents of droughts appeared to have stressed the agricultural societies. That was work that I and some colleagues did in the late 80s to mid 1990s. So that's an example of a reservoir project, and I'll come back to that in a bit. I've talked about it a bit for reasons, but we're going to need a national, indeed global level of effort moving forward. And in one area, this is going to be critically important is in information management. A grand challenge for archaeology paper that came out a few years ago said that basically documenting information, compiling it systematically is going to be critical to do large-scale planning and analysis. For a number of years now, I've been compiling archaeological information, information about artifacts, databases like PIDBA. These are team efforts. Over 100 people contributed to PIDBA. Archaeological sites with DINA, the Digital Index of North American Archaeology, linking site data from site files to a wealth of other resources. We're still going with that. And something that we will need to have moving forward is large scale. We need to consider not just the effects of climate change in one place or area, but much more broadly. So I consider this to be a priority. It's been what I've been focusing on. For 8 years now, my colleagues and I have been asking people, site file managers, state archaeologists, SHPOs to contribute data to the project. Basically, it's still growing. We could have a national archaeological database in place in 1 to 2 years, but the problem has been many states are reluctant to make the information available to share it. The Southeast is different in that regard, but that's been a challenge. So other areas we need to consider, we need to have appropriate site discovery, fieldwork analysis, and reporting efforts. A wonderful approach that's recently appeared is using LiDAR to find sites through subtle changes in elevation. They can be used in this case for shell rings, but they can also be used to find earthworks, rice dikes, roads, structures, field roads, and so on. And Davis et al. Have shown how this can be automated to target large numbers of sites. Other approaches are geoarchaeologically informed analyses, looking at how changes in stream or river channel, for example, siltation and so on will affect where sites are located, where they're threatened, and so on. This is J.R. Mehta's wonderful work in Delta. This is a technique that colleagues of mine, Katie Corcoran and Amy Bundorf at Tennessee, developed. They did a LiDAR flight over at Shiloh. They were looking for mass graves that were associated with the Civil War. But I had them fly over the Mississippian mound group that I had mitigated. And you can see the palisade features on the left. You can see small circular house mounds. Basically, the site had never been plowed since the battle. So there's remarkable preservation. Mound A on the right is where I focused the work. And the LiDAR was useful for showing the extent of erosion since we did the work. We stabilized the mound 20 years ago, but in the years since, I used 28 trucks of clay dump truckloads of clay, and the LiDAR was able to show the extent of mound erosion in different parts of the mound. We can also use techniques like remote sensing. This is at Etowah, to prioritize excavation. So moving forward, we have a lot of tools that we can use to guide our investigations, survey, to target sites, and then to how we proceed to evaluate them. Now, what we recover has to be maintained and saved for the long term in secure facilities. They have to be, putting curated materials in coastal areas is probably not a good idea in the long run. They're going to have to be inland and stable areas. That's a challenge moving forward. And it isn't just stabilizing and storing materials, but they have to be accessed and used moving forward. The last thing we want to see is something like this, where it's boxed up, piled away, put away, and it's never seen again. This is from Raiders of the Lost Ark, if you remember that scene at the end. Every stage of the process, our results should be publicly reported and widely shared, and they should guide subsequent investigations. Now I'm going to wrap this up in the next 10 minutes with an example from the Russell Reservoir project on this effort. The Russell Reservoir project had a technical synthesis that Joe Joseph and I wrote, several hundred pages, I guess. There were also popular overviews. Literally 8,000 to 10,000 copies of these were produced and sent to every school in Georgia and many locally, not just of the archaeology, but also of African American life. 2 popular volumes were put out. So that was one way. Now, of course, with digital platforms, we can do a lot more. So how do we estimate the site incidents on lands threatened by sea level rise? Well, the DINA study that I did with colleagues a few years ago showed that roughly 50,000 square kilometers will be lost in the Southeast this century. Now, in terms of the sites that we already know about, we already know of roughly 500,000 sites in the Southeast alone. What I did was you can look at this map and you can see that there are some areas, typically federal installations, that have received intensive survey. Ohio, by the way, was reported to us at the county level, not at the just a general, much finer scale. So typically where there's a concentration, it's where there are a lot of sites, and that's typically where there's been a lot of archaeology. So we have to tease that apart. And I looked at a number of these locations to look at site incidents in the areas threatened by sea level rise. So here's an example. The Francis Marion National Forest has some 2,000 sites that have been recorded. These other highlighted areas are other places. So looking at these sites, locations, Fort Stewart, Fort Benning, Camp Lejeune, Fort Pogue, the Francis Marion, and then I found a volume that had the numbers of sites per area across the Department of Defense. Basically, what we already know about is that in intensively surveyed areas, there's roughly 1 site per 109 acres. That's in areas where there's been a lot of cultural resource work. Remember the Russell Reservoir, there was 1 site per 71 acres, which was pretty good. That's comparable to what Fort Polk and Fort Benning had found. Now, how many sites are out there? How many are we missing? Well, basically, if you look at the areas threatened by sea level rise versus the numbers of sites in those areas, it's averaging about 1 site per 600 or 700 acres in terms of recording. Now, that means that basically there's probably at least 6 or 7 times as many sites that we haven't found and recorded yet. This is based on using intensively surveyed areas. So there's a lot more out there we need to consider. And of course, in different environmental settings, there'll be different numbers, of course. So the numbers are far greater than what we currently have. And this all depends, of course, on what we mean by a site, what we ignore or miss. Past research leads us to expect things, areas to consider. We need to be questioning all of these assumptions. So we need to be reassessing our predictive models continually. The Francis Marion had a wonderful predictive model primarily for pre-contact sites developed about 12 years ago by Jason O'Donoghue. One of my colleagues, Catherine Parker, has shown that for historic sites and recent historic sites, this model is not particularly useful. So we need to develop multiple models for different resources. So how do we estimate the cost of all this work? And this is just looking at sea level rise for both survey and mitigation. Now, the Department of Defense and other agencies, of course, have come up with guidelines for cost estimation for survey work. The costs vary widely depending on intensity of past occupation, the kind of effort we put in. Do we walk over the surface? Do we dig systematic shovel tests, and at what interval? And then what are the analysis and reporting and curation costs? But a ballpark for survey is roughly $100 to $1,000 an acre. So we can use those numbers to guide what the survey costs in the Southeast will be ballpark estimates, depending on cost per acre. You can look at it at $100, $500, $1,000 an acre. As you can see, the numbers are staggering. At $100 an acre, the threatened area is about 1.2 billion, and it could go as high as 12.2, depending on the cost of the survey in the area. Now we can also estimate mitigation costs. Remember the Russell Reservoir, 215 square kilometers? That was $15.8 million in today's dollars, the cost of one reservoir. The area threatened in the Southeast is 250 Russell Reservoir areas in this century alone, 50,000 square kilometers roughly. So looking at the cost of that mitigation project, which by no means was complete, we would look at a lot of things today, although a lot of things were looked at that were not at that time by many projects. We're looking at 250 times roughly 15 million. We're looking at nearly $4 billion in mitigation costs if the coastal area was treated like a past reservoir project, and that's in current dollars. Now, people have lived near the coast for at least 6,000 years. So there are a lot more sites within the 2 to 3 meters of current mean sea level. So I would say that the actual cost of mitigation is going to be several times larger. And I just, as a ballpark, said, okay, let's multiply that 4 by 3 to say that the mitigation cost for things like shell rings, for the historical record and so on, we're looking at roughly $12 billion in mitigation costs. If we look at those sites in the Southeast, and again, take a planning perspective like that. So to conclude this, climate change does pose tremendous challenges for our profession, for our civilization. However, we've faced these challenges before in our professional history, although not at this scale. But there are, as an example, some 8,000 major dams and reservoirs that have been built in the United States in the last century. And an example of one of those projects during the Depression era was the TVA. We're still working with materials recovered during those times. So we've met these challenges before, we can do so again. And the modern CRM era, in many ways, was founded by people like you all, people who are putting the papers forth. When I was starting in archaeology, I was fortunate to go to the University of Arkansas and take courses and be mentored by Hester Davis. She published a very critically important paper in Science in 1972, The Crisis in American Archaeology, basically calling for a need to deal with the loss of resources that were occurring. We're at that point again, and we are seeing wonderful papers by people in this group. The Kohler and Rockman paper is just one of many examples like that. And many people in the profession at the time, the leaders of the profession, lobbied the organizations saw to it that laws like the Archaeological and Resource Conservation Act of 1974 were passed, allowing up to 1% of federal funds to go for heritage mitigation. We're at that point again. We need to be thinking about those things. So to conclude, I consider this a great challenge for our civilization, but also our profession. We all need to be invested in the effort. And so this forum and many others like it are going to be needed. And I thank you all for what you're doing and for all your efforts. So live long and prosper.